Welcome to Systems of Equation. So here's an example of a system of equation, and these are what they look like. Okay, we're going to take a look at solving systems of linear equations by graphing, substitution, elimination, and using Desmos. So years ago, you learned how to solve systems of equation by graphing, substitution, and elimination. Our constant our concentration will be building the systems of equations from word problems. We'll use Desmos to solve the equations. So you're going to open a new tab and put in desmos.com, sign in with Google, and use your student account. You will use the calculator and type in equations after you create them. There are three possible outcomes when graphing two linear equations in a plane. One point of intersection, and so one solution, parallel lines and no solution, coincident lines, and so an infinite number of solutions. If there is at least one solution, the system is considered to be consistent. If the system defines distinct lines, the equations are independent. Let's take a look at this table and these graphs to see what's happening. Notice that in our first graph, it is of intersecting lines. So the number of solutions is exactly one, and we call this consistent and independent. Okay, if all you do is have one line, in other words, it's the same line just described two different ways. So the same line. This is infinitely many solutions. This is considered consistent but dependent. However, if we have parallel lines, there is no solutions and it is inconsistent. Okay. In similar fashion to what you found in the last section, use of the addition method to combine two equations might lead you to results like this. Please notice that if you wind up getting two numbers that are the same number and they're equal to each other, then you have the same line. Conversely, if you wind up with two numbers that are different, then these are parallel lines. That is our review for systems of equation. Now let's take a look at what we do with word problems. We need to understand the problem. Read and reread the problem. Choose a variable to represent the unknowns. You will have two unknowns. Construct a drawing whenever possible. Propose a solution and check. Translate the problem into two equations. Solve the system of equations. Interpret the results. Check proposed solution in the problem. State your conclusion. Here's our example. One number is 4 more than twice the second number. Their total is 25. Find the numbers. Read and reread the problem. Suppose that the second number is 5. Then the first number, which is 4 more than twice the second number, would have to be 14 because you would add 4 plus 2 times 5. Is their total 25? No, because 14 plus 5 equals 19. So our proposed solution is incorrect. But we now have a better understanding of the problem. Since we're looking for two numbers, we will assign x as the first number and y as the second number. So one number is 4 more than twice the second number. So x is equal to 4 plus 2y. Their total is 25. So if we add x plus y, we get 25. Notice that that gave us two solutions, okay? So that's the system that we're solving. Okay, once we have our equations, now we can just enter them into Desmos and click on the intersection point for the answer. When you do this, notice that y equals 7 and x equals 18. Okay, if we substitute x equals 18 and y equals 7 into both of the equations, okay, then you'll notice that the answers are true. Okay, so the two numbers are 18 and 7. Okay, let's take a look at a second example. Hilton University Drama Club sold 311 tickets for a play. Student tickets cost 50 cents each, and non-student tickets cost $1.50. The total receipts were $385.50. Find how many tickets of each type were sold. So, suppose the number of student tickets was 200. Since the total number of tickets sold was 311, the number of non-student tickets would have to be 111. But would those total receipts be $385.50? So admission for 200 students would be 200 times 50 cents or $100, while the admissions for 111 non-students would be 111 times 150 for just $166.50. Okay, so this gives total receipts of 100 plus 166.50, which gives 266.50. Our proposed solution is incorrect, but hopefully you can see what we're doing with the problem here. So we're looking for two numbers. We're going to let S equal the number of student tickets and N equal the number of non-student tickets. Okay, we know that 311 tickets were sold for the play, so that means S plus N equals 311. We know the total receipts were $385.50. So the admission for students must be 50.50 times the S plus 1.50 times N in order to get the total receipts of $385.50. Okay, now we have two equations. S plus N equals 311 and 0.50S plus 1.50N equals $385.50. Now, in order to type these into Desmos, we're going to have to change the S to X and the N to Y, okay? And when you do that, you will find the intersection point, okay? So your intersection point is at Y equals 230 and X is equal to 81, okay? If we substitute these into both of our equations, we will see that both sides are true. Okay, so 81 tickets were student tickets, 230 were non-student tickets that were sold. Okay, let's try solving a geometry problem. The length of a rectangle is 10 more than twice the width. The perimeter is 70 units. What is the area of the rectangle? Read and reread the problem. We have to remember we have two equations for the rectangle. We have a perimeter that is equal to 2 times the width plus 2 times the length. And we're going to have to use the area at the end, which is width times length. Okay? So the first sentence said that if the length is 10 more than twice the width, we have length is equal to 10 plus 2 times the width. Let's change the L to X and the W to Y. So X is equal to 10 plus 2Y. Okay? We're given that the perimeter is 70 units. Using the perimeter formula, we can find our second equation. 70 is equal to 2x plus 2y. So using Desmos in the two equations, because we have x equals 10 plus 2y from the other page, then we will get what for our intersection point. Okay? So yes, your intersection point should be x equals 26.67 with the y being 8.33. But the problem then asks you for the area, so you'll need to multiply them together to find your area. Thank you for participating. This is the end.